In this chapter, we're going to learn about quartiles and percentiles. Before that, let us look at a set of data showing the number of books read by a group of students per week. Do you remember how to draw a bar graph for this set of data here? Yes, a bar graph will look like this. We have 20 students here reading one book per week, as shown in this table here. Now, the number of students on the y-axis is also known as the frequency. Next, can you remember how to draw a histogram? Yes, a histogram will look like this. So what is the difference between these two? Can you tell which is a bar graph and which is a histogram? A bar graph has gaps in between while a histogram does not. Otherwise, it will look fairly similar. Next, we shall learn how to read a cumulative frequency table. To do that, we shall look at the data showing the number of pebbles of different weights. Now, this table here is called the frequency distribution table. Now, what this represents is that for pebbles with mass between 40 and 35 grams, I have 20 of them. To represent this on a histogram, it will look like this. So between 35 and 40 grams, I have 20 pebbles. And I can represent the rest of the data in the same way. Now, it is necessary for you to know that these inequalities here are called your class intervals. And hence, we have 5 sets of class intervals here. Next, we shall look at how to convert a frequency distribution table to a cumulative frequency distribution table. Can you see what is the difference between these two tables? Yes. Here we have cumulative frequency instead of the word frequency, and the inequalities here is different. Now, looking at the histogram here, can we find how many pebbles do we have that has weights of less than or equals to 35? Since there are no pebbles with weights less than or equals to 35, the answer here will be 0. How many pebbles have weights of less than or equals to 40? Yes. We have 20 pebbles with the weights of less than or equals to 40. What about the number of pebbles with weights less than or equals to 45? Since all these pebbles here have weights less than or equals to 45, we now have 80 pebbles. For less than or equals to 50 grams, we have a total of 195 pebbles. For less than or equals to 55 grams, we have 280 pebbles, and for less than or equals to 60 grams we have 330 pebbles. Now, to give you a better understanding of how we get these numbers here again, let us relook at the tables once more. Since there are no pebbles that's less than or equals to 35 grams, so we will write 0 here for the cumulative frequency. For less than or equals to 40 grams, which is this class interval here, we have a total of 20 pebbles. For weights of less than or equals to 45 grams, we will have these two class intervals here that satisfies the weights. And hence we will have altogether 80 pebbles. For less than or equals to 50 grams, we have these 3 class intervals that satisfies the weights. And hence we have a total of, by adding up, we will get 195 pebbles. For less than or equals to 55 grams, we have a total of 280 pebbles. And finally, for a weight of less than or equals to 60 grams, we have 330 pebbles. And hence, this is how we convert a frequency distribution table to a cumulative frequency distribution table. Next, by plotting these points here, we will actually get a cumulative frequency curve. You may be curious at this point how the curve actually looks like. Now, let us plot these points here. First, do take note that the y-axis is now called your cumulative frequency. The first coordinate is actually 35, 0, and hence the first point is here. The next coordinate is 40, 20, and we will have a coordinate here. Next, we have 45, 80, which is here. 50, 195, which is here. Then we have 55, 280, which is here, and finally 60, 330, which is here. Can you imagine how the curve will look like? Yes, it will usually resembles a S shape. Now, do you know what is the value here? No, this is not 50. Instead, we will read it as less than or equals to 50. And hence, do remember to read this value as less than or equals to 50, this value as less than or equals to 40, this value here as less than or equals to 35. Now, this is very, very important for answering our next set of questions. We will now look at how to read a cumulative frequency curve. We are given a set of data showing the speed of 350 vehicles passing a particular road junction. The first question is, find the number of vehicles with speed less than 44 km per hour. As you know, 44 is given by this point here, and the number of vehicles is 240. Therefore, we have 240 vehicles with a speed of less than 44 km per hour. Now, do recall that all these values here represents less than. Next, we are asked to find the number of vehicles with speed more than or equals to 54 km per hour. So, is the answer 310? No, definitely not. Why? Because 310 represents the number of vehicles with speed less than 54 km per hour. So how do we find the number of vehicles with speed more than or equals to 54 km per hour? Since 310 is less than 54 km per hour, we will use the total minus 310, which will give us 40 vehicles with speed more than or equals to 54 km per hour. Next, we are asked to find the percentage of vehicles with speed more than or equals to 30 km per hour. So what do 80 and 30 here represents? It represents we have 80 vehicles with speed less than 30 km per hour. To find the number of vehicles with speed more than or equals to 30 km per hour, yes, we'll take the total minus 80. And hence we have 270 vehicles with speed more than or equals to 30 km per hour. To find the percentage, we'll use 270 over the total multiplied by 100%, which is equals to 77.1%. Now, how do we get these two values here? The total here is found from the last cumulative frequency value from the curve, which is 350. Next, we are asked to find the percentage of vehicles with speed between 35 km per hour and 45 km per hour. So what do you think is the answer? Yes, to find the values in between here, which is these values here, we will simply use 250 minus 140, which is 90 vehicles. To help you better understand how to read a cumulative frequency curve, let us look at yet another example. Now this data here shows the test mark of a group of students. Using the graph, find the number of students with more than or equals to 21 marks. Is the answer 48? Definitely not, because 48 represents the number of students with less than 21 marks. Again, do remember that these values here all represents less than. To find more than, I have to use the total, which is, yes, 62 here. Now, do remember, do not just simply read off the last number, but do read off from the graph instead. So I will have 14 students with marks more than or equals to 21. In summary, given a cumulative frequency curve, do remember to read the answers from the correct axis. The value at the x-axis is always less than. For example, the value here shows less than 45. To find more than or equal, you always need to use the last cumulative frequency value here from the curve. And hence, to find the quantity that is more than or equals to 45, I will need to use 120 minus 104. Well, that's all for this chapter. Now do remember to highlight the important things that were mentioned here to help you better remember.